Jai Hind everyone, my name is Mukulit Goel and I am assistant professor in the department of MCA at AKGEC Engineering College, Ghaziabad. Today my topic for my presentation is network model for time estimation. It is from the subject software project management, paper code KCA 103. First of all, what are the contents for the presentation? The contents are formulating a network model, labeling a convention, adding of time dimension, the two techniques of one is forward pass, second is backward pass, then identification of critical path, and then in last how can we shorten the project duration. So first I will start with the network model, and what is this network model and how do we construct its rules. So the project network should have only one start node. If there is a more than one activity start at once, invent a start activity with zero duration. So with this, what we want to say that our project will start with a zero duration. Second, a project network should have only one end node. A node has a duration and the links between these nodes does not have any duration. Means the nodes have durations but their links does not have any duration. Then precedents are the immediate preceding activities. Precedent means like we are developing any software and there are two parts. One is hardware requirement and another is hardware design. So all these two activities are dependent on each other. So it means precedence. Time moves from left to right. A network may not contain loops. We say network may not contain loop because if we see any loop in the network, then it will represent any error. A network should not contain tangles. Tangles means in Hindi we can say jaise swing hota hai ya which is tangible type of thing. So network should not contain any tangles. Now we will have to formulate a network model through its fragmentation. So in fragmentation, the installation cannot start until program testing is complete. So program test cannot start until both code and data take on has been completed. So we start with the one fragment which is code and data take on. Then we test our program and after that we install our project. So after coding, before testing, we cannot install any project or any code into any system. Then what if it contains a loop? If network contains a loop represents an error. A loop is an error in that it represents a situation that cannot occur in practice. And what our motive? Our motive is to remove this loop. So program testing cannot start until errors have been corrected. So we have to remove this loop. What we'll do? First we code like I have shown earlier. First we code. When we come to program test and if there is a loop, what we'll do? First we diagnose the error. Through which error this loop is generating, and after diagnose we correct that error and then again we test the program and release our program. Means the error have been removed from our program. Next, formulating a network model, a tangle. A tangle activity such as write user manuals should not exist as it is likely to lead to errors in subsequent analysis. We cannot write a user manual after a code. What we have to do? We have to write a user manual after installation or training. So what we'll do? We first design a program, then we code a program, then we test a program, then we install a program, and what we'll do? We write a user manual while we do a coding. So how we resolve this tangle? For resolving this tangle, we should redraw the network with the final completion activity. What we'll do? We design, we code, we test, we install, and after coding, what we'll do? We write user manual. But when we will show this user manual, when we complete our installation and we are closing this project activity. after, like we see when we order any product, what we see, we have got our user manual within the box. In that user manual, what instructions we have? The instructions we have are the how to use that software or how to use that product. So the user manual is been right when the code the program, but when we use that user manual, we use that user manual after installing the program. Next important thing is what is the labeling convention. After drawing this network model, after formulating this network model, what is our labeling convention? So in labeling convention, this activity description is divided into 9 boxes, okay, and this is the standard naming convention which we adopt, in which the first label is about the activity, the second label is about the duration, the center is the description of that activity, left hand side is the earliest start and the latest start, and right hand side are the earliest finish and latest finish, and at the bottom we have activity span and float. So when we add any timing dimension into our project network model, what we'll do, we adopt a critical path approach. In critical path approach, we plan the project in such a way that it is completed as quickly as possible, and if there is any delay, then we have to find out and identify the activities through which our project is delayed. The method requires the estimation of duration of each activity, and this method of estimation of each activity is, there are 2 methods, one is forward pass and another is network pass. In forward pass, what we do? In forward pass, we calculate the earliest date at which the activity may commence and the project completed, and in backward pass, we calculate the latest start dates of our activities and the critical path. So what is the difference between the earliest date and the latest date? Earliest date are the dates on which we can start, initially we can start, and the latest date are the dates on which after which date we cannot delay our project. So let us understand with one example in which we have 8 activities, activity A, B, C, D, E, F, G, H. There is a duration 6, 4, 3, 4, 3, 10, 3, 2. It's are the weeks. It is in the weeks. It is the example of estimated activity duration, and it also shows the precedence. So activity C is dependent on activity A. Activity DE is dependent on activity B. Activity G is dependent on E and F, and activity H is dependent on activity C and D. So what is the activity A? Activity A is hardware selection, means when we are going to design any product or any project, what hardwares we need. Activity B is software design. Activity C is install hardware. So if we cannot select any hardware, how can we install a hardware? So after selection, what we have to do? We have to install all those hardware. And after doing the software design, what we'll do? We code and test the software. Okay, so the activity D is precedent on activity B. File take on is also dependent on activity B. Then we write a user manual, which we write after the code, and we give the user training. So we give the user training on the basis of file take on and the user manual. So the user training is dependent on activity E and F. Unless you cannot write the user manual or you cannot take files, you cannot give a user training. And when you give a user training, then what we have to do? We have to install and test our system. So the installation and testing of a system cannot done without installing the hardware and completing our coding. So the activity H is dependent on activity C and D. Now understand it with that model, like I have shown it earlier. It is divided into 9 boxes, and the 9 boxes are in the way. First, we have a activity label and duration. So our activity label is A, B, C, D, E, F, G. Then we have a duration and earliest start date and finish date and latest start and latest finish date. So with this network model, our label is A, which is hardware design or hardware selection. Then what we'll do, we install the hardware which is dependent on A. So the activity A will start after its duration is 6 weeks. Activity C have duration of 3 weeks. Activity B have duration of 4 weeks. Activity D have duration of 4 weeks. Activity H have duration of 2 weeks. Activity F have duration of 10 weeks. Activity E has the duration of 3 weeks and activity G has the duration of 6 weeks. So what we have done, we have done a initial work in which we label our activity, then we write the duration which is required by the activity and description of that activity. After this, what we see, when we start the forward pass, that activity A, B and F may start immediately and the earliest date of their start is 0, because A, B and F activity is not dependent on any other activity. So these are the standalone activities, so they can start immediately. Okay, so activity will take 6 weeks, the earliest it can finish in 6 weeks. The activity B will take 4 weeks, so earliest it can finish is in 4 weeks. Activity F will take 10 weeks, so earliest it can finish in 10 weeks. Okay, now we come the earliest start date. So activity will start as soon as A is finished. So the activity C will start after completing of week 6. So after completing the activity of A and C, the total weeks completed are 9. So in the same way, activities D and E cannot start until the B is complete. So the earlier they can start is the week 4. So week 4 is the duration at which the activity B has to be completed. So activity D will take 4 weeks, so it will become 8, and activity E will take 3 weeks, so it will become 7. So activity D will complete in 8 weeks and activity E will complete in 7 weeks. Again, the activity G cannot until start the both E and F have been completed, so it cannot start until week 10. Later of activity F and 10 for activity, later of week 7 for activity E and 10 for activity F, and it takes 3 weeks more, so it will finish in 13 weeks. Similarly, activity H cannot start until week 9, the later of the two earliest finish dates for the preceding activities of C and D. Okay, so the project will complete when both the activities of H and G have been completed. So the earliest project completion date with the later of weeks 11 and 13, so that is week 13. So this activity, according to forward pass technique, will complete in 13 weeks. So the forward pass and the network after. So what we do after forward pass, we write the earliest date, earliest start date and earliest finish date. So we fill up the second column of this precedence network model after activity labeling. So the earliest start of A, B and F is 0, 0, 0 and earliest finish is 6, 4, 10, and the activity C starting is 6, so we write it 6, 6 plus 3 duration, it becomes 9, 4 plus 4 becomes 8, 9 plus 2 become 11, 0 plus 10 become 10, 4 plus 3 earliest date and the duration becomes 7, and for G it will become 13, 10 okay, it will become 13. how it becomes a 13? It becomes 13 as BE. So it will become 7 and 6 weeks of them. So 6 weeks, 7 plus 6 is equal to 13. So after this, it will finish the project in 13 weeks. Now we come the backward pass in which we calculate the latest activity date calculation. So the latest completion date for the activities of G and H is assumed to be 13. So activity H must therefore start at week 11, at least at the latest 13 minus 2, and the latest start date of activity G is 10, 13 minus 3, as we see in the 13 minus 3 and 13 minus 2. So it will become 11 and 10. Now we come another step, which is latest completion date for activities C and D is the latest date at which the activity H must start, that is week 11. So the latest start date of week 8, 11 minus 3, and week 7, 10 minus 3 respectively. For activities E and F must be completed by week 10. Activity B must be completed by week 7. Activity A must be completed by week 8. And the latest start date for project start is earliest of the latest start date for activities A, B and F. So that is week 0. So after this, what will we do? We have filled it with the latest start date and latest finish date. So the delay in hardware design can be only of 2 weeks. Delay in software design can be only of 3 weeks. Delay in coding of the software can be of only 7 weeks. So with this we can identify the delay, and now what we have to do, the next step is we have to find out the span, and before span what we do, we have to find out the critical path, the one path through the network that define the duration of the project. And after we have to find the float and the span. The float is the difference between the activity earliest date and its latest start date, and span is the difference between the earliest start date and latest finish date. So after filling it with span and float, it becomes 8 weeks for the span. So it becomes the 8 for the activity A, 8 weeks for the span, and float will become the 2 weeks. So in this way we have filled all this network precedence model and find the critical path, and the critical path is start, then 10 weeks and then 6 weeks we have to finish through this critical path. So what is the significance of this critical path? The significance of this critical path, in managing the product we must pay particular attention to monitoring the activities on the critical path, and it is the path that we must shorten if we want to reduce the overall duration of the project. So what we'll do, we measures our free float and interfering float. Free float are the time by which an activity may be delayed, and the difference between the total float and free float will be known as the interfering float. So how we can reduce the duration of this activity? We can reduce the duration of this activity by applying the overtime or procuring the additional staff. But from this model, what we can see, that we can minimize or we can reduce the duration of activity F by 1 week. So this project will complete, instead of 13, this project will complete in 12 weeks. So through this network model, what we identify the duration depending on these activities, which are hardware selection, software design, install hardware, code and test of the software, file take on, writing user manuals, user training, and installation and testing of the system. So by taking these 8 activities and their duration, we can find out that in this example the project is completed in 13 weeks. It can be completed in 13 weeks. With this I am finishing my presentation. Thank you very much.